Perfect.
All righty. So I think we're recording now, so we're good to go. All right. So, thanks for bringing that
Hold on one sec.
up. Okay.
One sec. It's not coming up on my screen. I'm trying to get it to show up. For
You're
whatever
fine.
reason, my board's not working. It's plugged in. Me? You think I can't plug a cord? Clearly not. There we go.
Gotta love
Uh,
technology.
yeah.
Oh, are we good or just
Yes, I just have to change
okay? You just let me know when we're good to go.
audio. I got you. Let's see. Do you all know which speaker the board will be? Oh, really? I don't know if that was it or not. Professor Doss, can you say something for me?
Yeah.
There we
Is
go. Perfect. All right.
okay.
Sorry. It's working. You're good
Can
to
you hear
go.
me now? All right, we're good. Okay. All right. So that's so funny because technology is always the bane of my existence. So hearing you on that end's pretty funny. Okay, so we're in week 5, lesson 5. And so what we're going to be looking at today is identifying reactants and products of a chemical reaction, write chemical reactions from its description. So that's where when being able to write formulas from names really come into play. Balance chemical reactions, determine if it recurs and different types and predict the product. So there's a lot. So if we don't get through all of it, I can bump it back to next week because we're still doing chemical reactions next week, but we'll see what we can get to. Okay, so we're just going to start off with a little bit about chemical reactions. Actually, a chemical reaction is just telling us what is happening when two compounds combine. So the reactants are always on the left side. You have an arrow, and that gives us our products. So, and you all know reactants make products. Products is the end deal. Okay. There are some symbols you may or may not see when you read a chemical, when you look at a chemical equation. You might see an S and they'll be in little parentheses. That means the substance, when it's used for the reaction, is a solid. You might see an L, obviously liquid. You might see a G, obviously gas. And then you'll see an AQ, and that means aqueous. Most of the things, unless it's like water, are going to be aqueous. Aqueous is just a compound dissolved in water. Okay, so that's all that is. Aqueous is just a compound dissolved in water. So you're going to see a lot of AQ. Okay, just so you know. Sometimes over the arrow, you might have a delta H, that means heat was added in. You could have an arrow going up. Well, delta H, if it's going up, it's given off. If it's going down, heat was added. You can also have just an arrow going up, meaning bubbles were given off. So sometimes you may see something on the arrow, and that's just telling you what is going on. Okay. So that's kind of just notations. Okay. So the first thing is identify products and reactants. So if I had something like, I'm just going to do, and which is and I wanted to know is what is carbon dioxide? Well, obvious carbon dioxide is a product. Or what is oxygen? Oxygen is a reactant. So as long as you know that on this side, anything over here are reactants, anything over here are our products, that's easy. So that's just basic stuff. What goes where? Okay. Now this next one is write balanced equations from its description. So I'm going to write some descriptions and we're going to kind of go through this. Okay. So now I write solution that way. Just I've written this way for 1,000 years, and it's just an easy, quick way for me to write it because you write solution all the time in chemistry. So a solution of lead to nitrate is mixed with a solution of sodium iodide. Solid. Okay. So a solution of lead 2 nitrate is mixed with a solution of sodium iodide to produce a solid lead 2 iodide and aqueous sodium nitrate. All right. You will see stuff like that, and you need to be able to write the chemical equation from that. Okay. So that's when I said you need to be able to write the formula from the name. If you still struggle with that, just reach out to me through email and I'll work some problems with you, whatever you need. Okay. So if you're struggling with that, please feel free to reach out to me. So if I had to write this in a chemical reaction, because all a chemical reaction really is the symbols that go with what's happening. Okay. So if you were a chemist, and you had to write this out every single time you did something, it would take forever. So it's much easier just to write a chemical equation. So lead 2 nitrate. Now, solution is aqueous because anything dissolved in water is called a solution. Okay, so then I could write a little AQ by it. So we know, is that lead 2 nitrate a solid or is it already dissolved in water? So this will tell you a lot about what's going on. Is mixed. If you're mixing something, you're adding it together. So you can put a plus sign. Now it might say is added to, is combined with, anything that's a term that actually means you're joining it together. We're going to use a plus sign. A solution of sodium iodide. So, and I'm going to put a little AQ there. To produce, arrow. Anytime you see to produce, to make, to form, um, you're going to put the arrow because this is what our products are going to be. A solid lead 2 iodide and an aqueous solution of sodium nitrate. Okay. So if I was a chemist and I was working in a lab, it would be much easier to write what I'm doing like this than like this. And that's why they do it that way. Okay. So just kind of think about that. We'll do one more just to kind of show you, and then if we have time, we can work a little more. Okay. So barium hydroxide. Whoops. Solution is neutralized by adding hydrochloric acid. Okay. So it says a barium hydroxide solution is neutralized by adding hydrochloric acid. Now, we have not talked about how to name acids yet, so I would always give that to you. Like in the homework, I would give that to you because you don't know how to name an acid yet. And the resulting products are barium chloride solution in water. Okay. So barium hydroxide, it's a solution. So I'm going to put that little AQ is neutralized by adding. So I'm adding, so I know I'm making or putting a plus sign, hydrochloric acid. and that's given to you, which is nice. The resulting products. Well, this is telling me what's going on, which is an arrow, are barium chloride, which is also a solution, and water. Now, if it's at room temperature, and unless it's said anywhere in the wording that it's not at room temperature, we can assume water is a liquid. Okay, water is not a solution because it's water, it's in the liquid form. So we can just put the L. Okay, so the hardest part about doing something like this is writing the formulas and not forgetting what phase they're in. Now, if they don't tell you up, if it just said lead nitrate is mixed with sodium iodide to produce lead 2 iodide and sodium nitrate, you would not have to put any of the little phases because it didn't tell you. Okay. So unless it's specific in the description, you don't have to worry about it on my end. Okay. Now, if you were working in a lab, you would know it's aqueous, you would know, but here it's okay. All right, so that's how we write a chemical reaction from its description. Now, the next one is balancing equations. So, balancing equations, we have to balance an equation because of the conservation of matter. So, the conservation of matter states whatever we have before has to equal what we have after. So, when we balance equations, we have to make sure that we have the same types and numbers of elements on the one side equal to the same types and elements on the other side. Okay. So since I wrote this equation right here, we're just going to balance it. Okay. So this arrow, when you're balancing equations, basically means equal. Okay. So if I'm looking at this, I have to have the same types on each side. So I have barium on this side. I have to have barium on this side. If you have something on this side and it's not on this side, then there's something wrong. Okay. It just can't disappear. All right. So I have one barium over here. How do I know one? There's no subscript. I have one over here. Okay. That should be balanced. Now, you always want to do your H's and O's last because they just can be a little more difficult to balance. Also, if it is broken up, always do like here we have OH here and then I have an H over here. I'm going to balance H last. Out of the even though I'm balancing O's and H's last, I'm going to do O's and then I'm going to do H's because I have H in two different places. So next I'm going to look at my Cl. I have one Cl here. I have two over here. I have to multiply something by one to get two, which would be two. It always goes out front. Never, you can never do this. I'm just going to write this right here. Do not do this. That is not hydrochloric acid. That is something totally different. I don't even know what that is. It doesn't exist. You always have to put it out front. This is called a coefficient. It's put out front and it affects everything that is behind it. So before when I only had one H, now I have two H's, and that comes into play later. Okay. Now, when I look at this right here, all I have left is O's and H's, but I have H in two different spots. So I'm going to do my O's next. I have one O inside the parentheses, but we have to multiply through. So 1 times 2 is 2. So I have a total of 2 oxygens right here. I come over here, I only have one oxygen. So 1 times 2 is 2, so I put a 2 out front. So now my bariums are balanced, my chlorines are balanced, and my oxygens are balanced. So now I have to look at my H's. 1 times 2, I have 2 H's right here. 1 times 2, I have 2 H's right here. So I have a total of 4 H's. That's a plus sign. I should do it like that. I add them together because there's a plus sign right here. I have a total of 4 H's over here, so I have to 4 H's over here. 2 times 2 is 4. I have 4 H's over here. It is balanced. Okay. So we're going to do 4 or 5 of these so that you all can, see how it's done and feel more comfortable with it. Okay. So, um, let's do Cu plus O2 yields CuO. Oops, y'all need to be able to see that. Okay, so I have copper plus oxygen giving me copper 1 or copper 2 oxide. Okay. So now look at this. We always do oxygens and hydrogens last. So I have 1 copper, 1 copper. Cool, my coppers are great. 2 oxygens, 1 oxygen. So I know I'm going to put a 2 out front so my oxygens balance. Once I do that though, my coppers are now not balanced. So I have 1 copper over here, I have 2 over here. I need to put a 2 out front. Okay, so just so you guys understand that when I do this, when I put this out front, it affects everything, like I said, and that means you may have to go back and revisit something that is already balanced. All right, let's do another one. Let's see. And if you have any questions at any time, just stop and let me know. I'll give you a minute to write this down. Okay, so I'll give you all a minute, I mean, not a whole minute, I'll give you a little bit of time to write that down. But we have arsenic chloride with sulfuric acid to produce arsenic sulfide and hydrochloric acid. So when you look at this, you see this H here, so you know that's going to be balanced last. Okay. So when we look at this, 1 AS, 2 ASs. So I'm going to put 2 out front. Now, again, this 3 is affected, this chlorine, these 3 chlorines are affected by 2 out front, this coefficient. So 3 times 2 is 6. So I have to put a 6 outside of that because 1 is 6. Okay. Now, I'm going to now go to my S's. I have 1 S over here. I have 3 over here. So I have to put a 3 here. Once I do that, that 3 affects this 2. So it says 6 times 3, 2 times 3 is 6. I already have 6. So it's balanced. Now I'm just going to show you what this coefficient does. It says I have 2 of these. So it's like saying I have AsCl3, AsCl3. 3 of these, it looks like I have H2S, H2S, H2S. If I go over here, I just have 1 of these, and then I have 6 of these. I'm just going to show you why you have to use coefficients. Okay, so if I add everything up over here, so that's everything that's written based on my balance equation. I have 2 AS's right here. I have 2 here, I'm balanced. I have 3 plus 3 is 6 CL's over here. 1, 2, 3, 4, 5, 6. I have 6 over here. There, that helps it. Here, 2, 4, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 3. So that's why it's important to understand that when you put a coefficient out front, it affects this. So you have to multiply it because when I have 2, it's like writing it twice. When I have a 3, it's like writing it 3 times. I don't have, this is understood to be 1. Some students like to put a 1 out front, some leave it blank. Doesn't matter to me. I only have 1 of those and I have 6 of these. So that's why balancing those coefficients are important. And that's why you couldn't do this when you needed 6. When you figured out you needed 6, you couldn't do that because that then isn't right. Okay. You don't have 6 CLs, you have 6 HCLs. And that's what makes everything balanced. I just kind of sometimes like to explain that a little bit different way. Okay. We're going to balance maybe 1 or 2 more. And then we're going to talk about solubility. Okay, we may do that in a minute. Okay, let's do, I'm trying to do different things that you may see so that when you see it, you're not like freaked out about it. We'll do this. Let's see. All right, so I'll give you all a minute to write that down. And then we'll balance it. Okay, again, we go with the rules. H's are last, O's are last. Okay, but we're going to talk about that here in a minute. So, one AL, two ALs. I'm going to go ahead and put a two out front. Now, I have H's, I have S's, and I have O's. What you want to notice is I have SO4 here and I have SO4 here. If a polyatomic ion is the same on both sides, keep them together. It makes it 100 times easier to balance. Yes, you can break it up, but it's just going to be harder. So I have SO4 written over here, and I really have SO4 written over here. Since this is not in parentheses, I only have one of them. Over here, I have three of them. So I'm just going to go ahead and put my three out front. That balances all of it for me. I now have three S's and I now have 12 O's. Three S's, 12 O's. So you don't have to put the parentheses around there. Some of my students in the past have put parentheses when they see them on both sides because it makes it easier for them to remember to keep it together. But whatever's easy for you, that's fine. I now have six H's here. I have two here. I put a three here. It is balanced. Okay. I'm going to do one more and then I'll let you all try one just because I don't know. All right, so let's do, all right, so C3H8 plus O2 yields CO2 plus H2O. All right, so I'm gonna do two more, sorry, but I shouldn't have chose this one. Okay, so this is called a combustion reaction. Now, anytime you see this, always look at your H. We're not gonna balance it yet, but if it is an well, I'm not going to talk that. I'm going to do another one like it. Okay, so let's just start. So I have three carbons, three carbons. I have H in one spot, H in one spot, O in one spot, O in two spots. So I'm going to do my H's first this time. So I have eight H's, so I put a four over here. Okay. Now I have one O over here, or actually I have two overs here, but I have O in one spot over here. So I have six O's here, plus I have four O's, which gives me 10 O's. I already have two. I should use different colors. So a five goes here. Okay. Now, I'm going to do a different one that's still this kind of problem because I should have done this one to give you the trick, but it's okay. We can do it real quick. So C15H30 plus O2 yields CO2 plus H2O. All right. Now, the first thing you do when you see a hydrocarbon is a compound that just has hydrogen and carbon in it, right? Look at the hydrogen. If you cut it in half and get an odd number, go ahead and just put a two out front. It will make your life so much easier. Otherwise, you're going to drive yourself crazy. So when you see something like this, okay, it's called a combustion reaction, and we're going to learn about those in a minute. Always look at the hydrogen. If I divide it by two, because there's a two over here, is it going to be an odd number? If it's going to be an odd number, go ahead and double it. Okay. All right. So let's look what we got. 15 times 2 is 30. So I'm going to go ahead and put a 30 out here. All right. I'm going to do my H's next because my O's in two spots over here. 30 times 2 is 60. I'm going to put a 30 here. Okay. Now, I'm going to look at my carbons here. I have 60 carbons here. I'm sorry, oxygen's here. Maybe do that so I know it's an oxygen. And then I have 30 oxygens here. So that gives me a total of 90 oxygens on this side. I have two over here, so 45 goes here. Now, don't be afraid of large numbers, okay? However, I do want to preface this with, or I do want to tell you this, I shouldn't say preface, but don't be afraid of large numbers. However, if you get large numbers and they can be reduced, you need to have it in the reduced form. Needs to be in the reduced form. Okay. If it is not in the reduced form, then it's not really correct. Okay, so always look at and say, can I reduce these subscripts? If you can, because sometimes I'm going to say this, and I've seen it, I've taught this a long time. Some students, in order to get it balanced, get really big numbers. That's just how it ends up for them. And that's okay because if you get those big numbers and then you go back and reduce them, you're still getting the same thing as maybe someone who didn't. So always make sure it's in the reduced form. Okay. So that's balancing. I'm going to give you all one to do on your own just to see how you do, and then we'll move on. Okay. So let's do. Also, don't be afraid if it's really a big problem. Sometimes those are the easiest ones to actually balance, are really big ones. So don't be kind of freaked out if you get something big. Okay. I'm not giving you all a really big one, but I'm just saying that. Let's do. Okay. So I'll give you all a couple minutes and I'll write the answer and see how you all do. This is kind of an easy one, but that's okay. I'm going to give you one more. This looks a little more difficult, so I'll give you all two to do, just because this is important. If you can't balance the rest of the semester, you're going to struggle, just like the naming. Okay. Y'all just let me know when you think you got them both done, and then we'll go over them. And then if you have questions because you didn't get that answer, let me know. This is a four and that's a four. I need to make it a little bigger. Are we doing okay? Okay. I think I'm just going to go ahead and give the answers. And if you didn't get it or you have a question, let me know. And I'm going to explain it as I do it. Two V's, one V, I put a two out front. One calcium, one calcium, I'm good. Remember, you keep your O's to last. Five O's, one O, five. So now that five has affected that calcium, and I'm going to put a five here. Okay. Now, let's look. Everybody do okay on that one? All right. So let's look at this one. One Ca, one Ca. Now, this one's a little bit different because I have OHs here and I have an OH here. But if you notice, So I'm going to do those last, oxygen, hydrogen. I come here and NH4 is also together on both sides. So I'm going to go ahead and keep them together as well. Okay, so I have one NH4, one NH4. Those are balanced. Chlorine, one chlorine, two chlorines. I'm going to put a two out front. Now I have two NH4s, which means I have to put a two here. Now, two OHs, two times one, two OHs, it's balanced. So sometimes when they look crazy, because there's all these letters, there's all big compounds, they're the easiest ones to balance. Okay. All right. So do you all feel okay so far? Because I can either do a little bit more and do some more writing from what we did the very beginning, and then I can push the other stuff back. I mean, we have some wiggle room with some stuff. So I just want you all to feel comfortable. So do you want me to do more writing from the words, writing the equation from the words, or do you all feel okay with that? And you want me to move on? Just let me know. What do you all want to do? I can do either. I, I can't hear you all, so maybe speak louder.
Now,
We're good?
can you hear me?
I can now, yes.
Oh, okay. I think the consensus was they wanted to stay here and do more of this.
The balancing and the
Is that what?
predicting, the writing the
Yeah.
formulas from the words.
Yes.
Okay. So I will spend the rest of the time doing that. Just what I'm going to have to move is I'm going to have to go and rework some of the stuff on Moodle. So I'll have that done today. So I'll just move everything. It'll open tomorrow and it'll be due next Wednesday. Is that okay with you guys? I'll just switch everything a day. Okay. All right. All right. So we'll do a little bit more of this. And what I'll do is I'll write a few and let y'all practice. And then we'll do a little more of what I started with because that's probably the hardest thing. But this is very important that if you can do this, you're good. But if you can't balance equations, you will struggle the rest of the semester. And I just want everybody to understand that. So okay. All right, let's do another one. These Zoom days are very much y'all's days. So like I'm glad that you are like, hey, let's just stay here because I want you all to feel comfortable moving on. Okay, so it's aluminum sulfate plus calcium hydroxide gives us aluminum hydroxide and calcium sulfate. Again, don't let the ones with a lot of stuff going on make you think it's hard. These sometimes are your easiest ones. Sometimes your little ones are the hardest ones. So I'll work a couple more with you guys and I'll give you all a couple more to do and we'll go from there. Okay, so um, aluminum, I have two aluminums. I come over here, I have one. I've got to put a two out front. My aluminums are balanced as of right now. All right, SO4, it's together here. It's also together here. So I can look at how many SO4s do I have? I have three. So I come over here. I have one. Again, if you need to put it in parentheses so that makes sense that there's only one there, do that. That's okay. But I have three over here, so I have to put a three out front. Now, calcium, I have three over here now, and I have one here, so I have to put a three here. Now, on this one, on a hydroxide, it's nice because it's both in parentheses. Three times two is six. Two times three is six. Now, we're going to do another one, and I'll work it a little differently that it might help you to do it this way because I try to do it different ways for different students might do a little better, seeing it done a different way. I'm having problems speaking today. Okay, so let's try this one. And this is the one that we wrote out. So another way you could do this, and this might work for some of you because different people learn different ways and they like to do things different ways. So one thing you can do is you can list everything below it. So I have a PB. I'm keeping my NO3 together because it's on both sides. I have an NO3. Over here, I have an Na. and an I. Here I have a PB and an I, and here I have an NA and an NO3. You do not have to do it this way. I'm just showing you this way because some of my students in the past, this made more sense to them. So I have one PB, I have two NAs, one NA, one I, one PB, two I's, one NA, one NO3. Then they look at it this way and say, okay, I have one PB, I have one PB, that's balanced. I have two NO3s, I have one NO3, so I have to multiply that by 2 to get 2. So then I'm going to put a 2 here. Well, since I multiplied that by 2, I have to multiply this by 2, and I'll have 2. So now I know how many of these I have. All right. So then I go to my NA. I have one NA over here, but I have 2 over here, which means I have to multiply this by 2, which gives me 2. So I put a 2 here, and that means this is multiplied 2, gives me 2. So now my N, oh, I should have done this in blue. I'm sorry. I'm getting all tore up. So I have two NAs, two NAs, two I's, two I's. So they like to make sure it's balanced under here once they put it up here. To me, it's more work, but I've done this 100 years. So whichever way makes it much easier for you, that's what you have to do. I don't care. All right, let's do, okay, let's do this one. All right. I see this hydrocarbon here. The first thing I do is cut that in half. That'll be odd. It'll be 13. So because it'll be 13, I'm going to go ahead and double. All right, then I get to start. So I have 24 carbons. So, and I have 24 here. Okay, now I'm going to do my H's next because H is only in one place, but O's in two different places. So I'm just going to go ahead and put a 26 here because I'm doubling it and I have a 2 here. I can just put that there. So now I have to do my oxygens. I have 48 plus 26. I'm going to use a calculator for that. Well, let me just do this. 74. Okay. So half of 74 is 37. All right. I'm going to give you all a couple to do, and then we'll go over them and see how you do. Okay. Let's see.
Professor Doss,
Yes.
just so you know, we got until 9:42.
Oh, okay. Um, okay, so why don't we do this? Um, mm, okay. I'm gonna arrange the homework. Like I said, I'll open it tomorrow and it's just gonna be over this and the two things we did. Um, guys, please email me, text me if you're having problems. Like I can work a problem and then send it back to you through text. I can work a problem, upload it to email, send it back to you and explaining what I'm doing, especially what we did in the beginning. But please reach out to me because like it's my job and I just want to help you all be successful, okay? One other thing I just want to say some of you all have had some issues with Moodle. So from now on, if you all would just be proactive and if your Moodle's messing up, please let me know before an assignment's due, not after. Also, some of you all had several assignments that you couldn't get uploaded. I've graded everything. I put zeros in for those just because if I don't and you check Moodle, it looks like your grade's really good and you're still missing something. But once you turn that into me, I will change your grade. So if you look at your grade and it's low, don't freak out. I'm putting zeros in there because if you're like me, if I were to look at my grade and have an A, but I have a blank, I'm not thinking about that blank. But if when I put that zero in it, it's going to affect your grade. Then you can say, hey, I submitted that. Can you redo my grade? Okay. So two things, your grades are all updated. Look at it. If you have any questions over anything I've graded, please reach out to me. I don't mind to answer any questions you have. But if you still haven't turned something in because you've had Moodle issues, I've put zeros in for those so that you can remember you've got to get them done. From this point moving forward, if you have issues with Moodle, please let me know before the due date. A lot of you are letting me know after the due date. So just let me know before the due date. And if you're still having problems with Moodle and it's an ongoing thing, just let me know because I know the guy in charge of IT over there. I had his kids in school. So if the IT people aren't working with you all, let me know and I'll let him know. So, but if you need anything, please reach out to me, and I'll get this sent to Mr. Kalen so he can get it in your Teams, whatever, OneNote, whatever you all use. So you all have a great day. Does anybody have any questions?
Questions? Nope. Looks like we're all good.
All right. Thank you so much. Y'all have a
Thank
great
you.
day.
You
All right.
too.
Bye-bye.